Hey everybody, I'm Jonathan Payne, and this is my podcast for Fundamentals of Physics. I'm with Section 3, and I'm going to be doing the demonstration called Plop. And that's pretty much what I'm about to do. I'm going to plop some books into the floor. But before that, I wanted to ask a question. Why is it whenever you're in the car and you slam on the brakes, you get flung forward? The answer is simple. It's inertia. That's pretty much what I'm going to be talking about, the principles of inertia and momentum. And so if y'all ready, let's get to it. Alright everybody, I have a chair set up in the back. I got 5 books stacked on top of it. And then we got some padding down here on the floor so that we don't wake the neighbors when the books fall. Now what we're going to do is we're going to roll the chair real fast and then we're going to stop it quickly so that the books just fall. And then we'll explain why this happens after the experiment. So let's do it. There you have it, just as I said. Alright, so now for the explanation. Why did the books just fall? The answer is actually pretty simple. Momentum. Sir Isaac Newton deduced 3 laws of inertia. The one that is demonstrated here is the first law, which states that an object will continue in its current state of motion unless an outside force acts upon it. This means an object at rest will stay at rest unless a force acts upon it, and an object that's already in motion will remain in motion unless a force acts upon it. You can analyze the momentum of any given system. So for our purposes, we're going to say that the system is the chair and the 5 books that were in it. And to keep it simple, we're going to say that the mass of the 5 books is all one mass. So when you're talking about momentum, it's important to note that momentum is always conserved. So what you start off with is what you have in the end. If you start off with a given momentum, then that momentum has to be the same on both sides of the equation. Now, momentum is equal to an object's mass multiplied by its velocity. Let's say hypothetically the chair was going at a velocity of 3 meters per second, and that the combined mass of the books in the chair is 80 kilograms. We can use the equation P equals mv to solve for the total momentum of the system. P is momentum, m is mass, and v is velocity. If you multiply 80 kilograms by 3 meters per second, you get 240 kilogram meters per second. Therefore, the momentum of the system is 240 kilogram meters per second. Now, once we stop moving the chair, we can no longer treat the 2 masses as one because the books are going to split off from the chair, so we have to treat them as 2 different masses. So now we have 2 sides of an equation. We have the left side where the 2 masses are combined and the right where the 2 masses have split. Now here's where the principle of conservation of momentum comes into play. We already know that the left side of the equation equals 240 kilogram meters per second. So now we just have to solve for the right. Notice we have 2 masses and 2 velocities to work with now that the objects are splitting. Now I don't know the masses of each object specifically, but we know the chair is heavier than the books for sure. So we'll just say that the chair is 60 kilograms and the books are 20 kilograms. Since we know that the chair is going to be at rest, this means the chair will have no momentum. So we can just ignore that part of the equation. And now we just have to solve for the velocity of the books. So we divide 20 into 240 and we get 12 meters per second. Okay, so let's do a little recap. What did all these equations and problem solving really tell us? Well, once you stop the chair, all that momentum that it started off with the books is now transferred strictly to the books. So that means the chair has no velocity, and all the momentum that it had to be transferred to the books, which gave it all the velocity. And so once the chair stopped, the velocity of the books kept going because nothing was acting on it. So once it kept going, they fell to the floor. Alright, so that pretty much sums it up. I'm Jonathan Payne, and this has been my podcast.